So this is intended to be kind of what we did during the last year. It's because on the last Plone conference, we already presented a lot of things on Guillotina, and we were willing kind of to do what's the status of Guillotina nowadays, what we've been doing, what are our plans, and a bit of history also on top of Guillotina. So, first, me. I'm founder of 2 companies right now, Plone Foundation member, a musician, and I'm Catalan. You see my t-shirt, Catalan. And we decided to include images of the actual situation on our presentation. So, next one.
Yeah, hi. So, no, you're the next one. Yeah, I'm Nathan Van Gheem, co-founder of Guillotina, and yeah, I'm American. I just followed Ramon's sort of slide. That's why that's some other protest. It's not Catalan. Yeah, Plone Foundation member and work at ONA doing Guillotina.
Thanks. So my name is Eric Brehault. I also work at ONA. I'm a front-end developer there. I manage the front-end team, and I'm a Plone contributor. I'm also part of the Brehault team, and those are French protesters, you know.
Okay, so let's go. First, why we created ONA. Later we will go with the history kind of details that are a bit more interesting. But just to highlight some of the goals of what we are pursuing. We are pursuing something that is built on a Sync.io. And we will talk a lot about the Sync.io, so I'm not going to go deeper into that. We want something that has batteries included. What means is that can be delivered with Elasticsearch, cache system, distribution, that you can really create workflows, content types, everything that you need, kind of a bit the idea of Plone. But at the same time, you can deliver something that is really small, just this framework selling hello world on an endpoint. So we want to keep it simple, but that you're able to include batteries on the out of the box. It's built to scale. We will talk a lot about that, so I'm not going to go deeper into that. And inspired by the best in Python. So when Nathan and me started to work a lot on creating Guillotina, we don't want to reinvent the wheel. We don't want to start something from scratch again, like it's normal. So we decided, okay, let's copy the best from all the frameworks that we know. No? So we went to Pyramid and we say, okay, we love these decorators. So we are going to copy onto Guillotina. And in the spirit of Plone, which means, of course, we've been in the Plone community, I don't know, a lot of years, too many. And we decided to copy also the things from Plone that we love. For example, GCA and not GCML, Zone Component Architecture and interfaces. The schema and the traversal point of view and pickling objects, we will talk about that. So, and mostly the community. Guillotina, we are really happy that we are inside the Plone Foundation, and because it means that our code, our project is protected forever in the foundation. So that's great. We want to keep in the Plone spirit, and we hope that we can have a lot of histories together. And yeah, finally, and not least, we don't want only to be backend. Eric asked, do you have any screenshot for the keynote about Guillotina? And we say, okay, it's a REST API. I don't know what to screenshot. Maybe we can try, I don't know, to screenshot a JSON, wherever. But Guillotina wants also to be an history for front-end people who wants to build application, and we will talk a bit about that. So we want to build tooling, so building things with Guillotina on the front-end side, it's easy. So now, Nathan.
Sorry that we're going to keep swapping back and forth. Yeah, I want to go over some of the, in case you don't know that much about Guillotina, just give you an introduction to some of the things that we provide as features for the framework. Yeah, I guess the biggest thing, because we were a REST API, we were trying to provide a fast, very well-defined REST API. And that means everything is defined by JSON schema and OpenAPI 3. And with that, then we also have Swagger out of the box. So everything is defined by a spec that is, and all those JSON schema and OpenAPI 3 definitions validate the payloads coming in. And so like it's well defined and validated against the OpenAPI 3 spec. And it's part of how you define your endpoints too. So it's built into the framework itself as far as how you provide OpenAPI definitions. And we're still like a hierarchy content model, just like Plone, and have this similar security model. And we have like an auth framework out of the box with JWT and JWK as well. And I mean, we can have like really safe transactions with Postgres and WebSockets and cores out of the box. So all the things you need to build JavaScript applications. And lots of really cool features with async I/O for doing tasks asynchronously. Things that like you need to do after a request is finished, a different type, maybe indexing or whatever, but there's built-in utilities for doing these things, working with the async I/O, and cloud file streaming, and yeah, I don't know, Redis cache support with PubSub, and so lots of fun stuff that allows you to provide a lot of features for your applications. And yeah, so over the summer we had a sprint and a couple of sprints that we kind of worked on finishing up the features that we wanted to complete for Guillotina 5. And we released towards the end of the summer, I think, or around August. And some of the things that we wanted to improve with Guillotina 5 was the out-of-box experience. Because like before Guillotina 5, out of the box you couldn't get indexing and search. You had to install like an add-on, an Elasticsearch add-on. And so like now that we implemented a generic query parsing framework, so now you can pass the same queries, and if you're using the PostgreSQL search indexing or the Elasticsearch add-on, they both should parse the same queries. And had some improvements with the object cache and PubSub, and we moved Swagger into core as well. And I guess the other big thing was moving to Python 3.7. Python 3.7 has a really nice context vars API, and that context vars API translates really nicely over to async I/O. It allowed us to clean up a lot of our APIs internally. When we started with Guillotina, async I/O was new, and some of the patterns of how to accomplish things wasn't well defined yet. So in 3.7, it's kind of like a really important threshold for us that we are able to clean up a lot of internal APIs, and the async I/O library is nicer in 3.7. And as I was saying before, everything in Guillotina's core REST API now is OpenAPI 3 defined with JSON schema, and it's validated. And we're using the latest Swagger, and yeah, I kind of already went through some of that. Some other things, more MyPy support. So if you extend Guillotina, you can get just more support for type checking. And we improved the cache hit and write performance of Guillotina. And again, related to the context vars better transactional API to make things a little bit nicer developer experience for people using async I/O, and then the search query API as well. And I'm gonna let.
Just to mention, MyPy, it's really important. I know Nate did a nice talk about that, or at least he said to me. But it's really important that we have MyPy, because it helps a lot the developer experience. I really love it. Okay, so what we were planning to do now is to go through the use cases. I think it's one of the most frequently questions I've been asked. So are you using Guillotina? It's ready for production. Which use cases are you using Guillotina? So we try to, yeah, we are using Guillotina, we are using in production, we are using a lot in production, and we are trying to just summarize some of the use cases without names in some of the cases, but just to explain where we are using it. No? So, first, CMS. I suppose that everybody understands what's the use case of CMS. This is, as far as we know right now, being used at Iskra, for example, that we are using for building any kind of CMSs, small pages, some small intranets, some bigger intranets. And we built our own frontend on top of this API, the Plone REST API. And we have workflows, we have content types, we have subscribers, everything that you have more or less in Plone. The backend supports it, but we are building our specific frontends. Why we are building our specific frontends is that our developers and our use cases are maybe so specific and they need a really specific frontend with some Angular application or whatever. Then for us it's easy. We are still not using Volto, but for us it fixed the problem to have an API where we can connect, save content, and publish content, and being able to have security and folders and etc. etc. The second use case is a bit complex to explain, but I will try to explain with an example. So there is an electricity company in Spain that they collect data of consumptions of all the consumers. Imagine, I don't know which is the one in Italy, but in Spain, Endesa, Factor Energia, there are a lot of them. So we collect this information, we process, we do kind of numbers of how much kilobytes you use today, at what time, blah, 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 blah. And then you also want to generate reports. And these reports needs to be managed with content management. So there is somebody who's choosing, I want the graphic, I want this graphic, I want these options, I want to translate these labels, whatever. So for us, it was a great opportunity to test Guillotina, and the result was really great because Guillotina supports two kind of databases. In this case, this is really useful. One is the Postgres database, where we are storing the data from all the different reports, the layout. We are using React Page for doing the layouts. And then another database that we are using, Cockroach, that is being able to scale a lot horizontally to store the data, which allows us to scale with hundreds of thousands of different users and data that we are getting every day. That use case, I don't know if with Plone will be possible, maybe having an external storage, of course, but for us was really great. The developers just needed to learn one API. The same API to access the data from the consumption is the same API that they use to access the layouts, to publish, to edit, to do whatever they want. It's also really great that besides having Postgres and Cockroach as databases to scale a lot to hundreds of millions of objects, there is also the option to use Elasticsearch. So if you have time series information, if you have a lot of information that you need to index, out of the box you have PG Catalog, that it's the standard one that you can index hundreds of thousands of objects. But if you want to use a massive amount of information that you need to index on Elasticsearch, you can use Elasticsearch out of the box without needing to worry about synchronization and indexation. Yeah, another use case that we are using, it's machine learning processing. So I don't know if you know some data scientists, but they are really difficult to deal with because they want to have the data in a CSV file. No? So they come to you and say, I want a CSV file because I'm going to build my model that it's the best thing in the world. Okay, but you know how much time it takes to export something, to create a CSV file. It's a lot of data, hundreds of thousands of registries, and you need to do that a lot of times because they need to update the models, blah, blah, blah. So one of the good things is that, thank you to the transactional API that Nathan mentioned before that we have in Guillotina 5, we have Jupyter notebooks that are connected directly to Guillotina, and we are able to run batch operations that are doing models, whatever kind of data scientist role they want to do, but they are able to get the information directly from the database, directly from Guillotina, with an iterator that you can send a search. Give me all the documents that has, I don't know, a tag called hello. And then you get all the objects. And then you can do any kind of work that you want to do, a batch work for processing or doing whatever. And we can do that with Jupyter Notebooks itself or with your own scripts on top of that. Oh yeah, and as we are using Pickles, and now Pickles supports NumPy array in 3.8, we are able also to store NumPy models onto the database, like standard Guillotina objects. Well, the use case of web and mobile applications, that's simple, no? You have a mobile application, you need to store your data. You could use Firebase. Lots of people are using Firebase nowadays, but you need to send that to the cloud. You need to pay to Google. Well, Guillotina is that kind of an API that it's similar. You have WebSockets, you have real-time communication, you have storage of data, you have transactionability, you have security. You could use that to store the information from your data, from your mobile phone, a mobile application, wherever you want. And now we have a use case that is really big, knowledge management. Well, knowledge management is so big that we decided just to focus on the use cases that we work daily. So now Eric is going to explain the ONA use case.
Yeah, so at ONA, we are basically providing a platform to index all the information managed by a company. And our customers are big company, big American company like Facebook or EA or Fitbit, this kind of big company. So they have thousands, millions of emails, of Slack conversation, of Jira project, G Drive stuff, Dropbox file, anywhere, everywhere in the company. So that's huge, as you can understand. And the thing is, with ONA platform, you can index all of that, wherever it is. You can make sure it's always in sync, and you can search across this big amount of information in order to retrieve knowledge, basically. So that's demanding. I mean, that's involving very big volumes of data, very big ability to scale, and that's where Guillotina is a perfect match, right? If you try to implement that with something different, which is not async IO based, for instance, or which is not providing this ability to index fast, etc., you will fail at some point, and you will not be able to adapt to all the situation where you try to get this big amount of information. And where ONA is really good at compared to other solutions to do similar things is we are able to integrate many different type of information because our platform is flexible. It's super easy actually to connect to a new third-party application like, I don't know, Dropbox, for instance, and just use their API to get information and push everything into the Guillotina backend, and then it connects to the rest, and it will work like any other kind of information. So that's this flexibility and this scalability are the key factor of success for Guillotina. I mean, using Guillotina here. Next one.
Yeah, we thought it would be good to talk about how Guillotina is different, maybe, than some of the other more popular frameworks or some of the frameworks that people here might be familiar with, just so you know how to like classify it if you're going to think about using it. Well, before I'll start, I'm gonna say this a few times during the conference. Async IO won. Like for a little while, there was like there was a lot of resistance, but I mean, if you even look at the latest Django improvement proposal, they're going to adopt async IO. and so like resistance is futile or something, right? You know, like we're moving to an async I/O web framework world. So like that, I guess I'm just gonna say that async I/O won. And like if there's any sort of like innovation left in the web framework world in Python, it's only in async I/O right now. That's where the only movement is. And so like Django is obviously really popular, and it's like really full featured out of the box experience for the most part. And it's got like the admin, the back end to manage content, and lots of tooling, lots of answers on Stack Overflow, but the REST API isn't that great. They have that add-on, but it's not really that nice of a REST API, but people use it a lot. And it's not fully async I/O. It will be maybe someday. But it's like, it comes from a world of templating. It comes from the days that when we were rendering HTML templates in Python. And Pyramid is a really nice framework. It's unopinionated, and it comes out of like sort of the Plone Zope heritage. And it has a lot of similar concepts to Guillotina as far as like how it's built. But it's not async I/O as well, and there's no batteries included. And then Plone, I hope you guys are familiar with Plone, so I don't know if I want to speak too much on that. Ramon would like to tell a little story of like why we have Guillotina though, and talk about how that relates to Plone.
Well, we are not going to do the comparison. There is the panel on Friday, so we are not going to fulfill this slide. I just want to explain. I know I've explained it a lot of times, but just I'd like to explain histories. 3 years ago already, I was starting the ONA, or starting to design everything. We needed to know how much information needed to be held there, and it was a really ambitious project. So I tried Plone. I knew Plone, I was on Plone, I was willing to use Plone, so I was starting to use Plone. And I was going deeper into Plone, trying to load a lot of data. After 2 months, I switched to RHEL storage, because ZODB, the memory was blowing up, the index of memory of the ZODB was not enough, the speed was really bad, not because of the ZODB, because all the cons that we have on the stack in the middle between Zope, CMF, and Plone, there is a lot of decisions that are really great for CMS, but not really great for building an application that needed to scale. So we were kind of struggling there and we were trying really, really hard. No? If we even were calling Gheem and we having calls with Gheem, how we can try to tune this more far away than what we have, because we need hundreds of millions of objects to be stored and being accessed so fast. No? And we've reached a really difficult wall on async I/O, because async I/O it's one of the keys that makes this, we will talk also about that later, so I'm not going to go there. But async I/O is one of the keys to make this happen. No? So ZODB is not able to have async I/O due to the design by itself, so we were kind of, oh my God, I've been in the Plone community a lot of years, and I still want to be in the Plone community, and I still want to have some Plone-related stuff. But what I want to build, I cannot use Plone, even the frameworks, even the lowest framework that we have on Plone. So then it was when we did a sprint in Barcelona, 15 people were there, and we decided to start creating Plone server and then Guillotina, and that was the history. Thank you so much for giving me the opportunity. Oh yeah, and it's me, sorry. Continuing with the use cases, one of the other questions I've been hearing a lot is, but Guillotina is only useful if you need massive amount of objects on your database. It's true. If you have massive amount of objects, it's a really good option. But it's really good for a small amount of objects? Yes. Yeah, and we use a lot for a small amount of objects, even 100, 1,000, 10,000, doesn't matter. But why? Because the memory footprint of Guillotina is so small. and the deployment requirements is so easy that it's so fast to deploy a Guillotina and to have it to support multiple kind of instances or multiple kind of Guillotinas at the same time with one Postgres, for example. And the good thing is that you're using Postgres, so DevOps guys love, because they have a lot of tooling around Postgres, so it's so easy to maintain, it's easy to know, to back up, to do whatever you want. So, we wanted to explain some deployment scenarios. Okay, monolithic, the numbers are a bit rough, sorry, because we didn't have time to do all the tests that we wanted to show the numbers. But, well, a monolithical one, that's a really simple one. We have one Guillotina and one Postgres, and Postgres is the indexing, no? You can deploy with one CPU, 2 gigabytes of RAM, and without problems, 1 million objects. You get to up to 1,000 requests per second on reads and 3,000 requests per second on writes. Of course, depend on the size of the objects. If you are pushing there 100 megabytes of objects, it's not going to go at this speed. But we are talking about standard CMS web pages, for example. It's cheap, but if you are turning down the Guillotina instance, you lose the service. A bit bigger, so 3 instances of Guillotina. Then you need Redis to do the PubSub synchronization of invalidation of data, a Postgres, and Elasticsearch if you want to index full text search or some kind of specific n-gram technology. Yeah, you see that we need 20 gigabytes of RAM. It's mostly due to Elasticsearch. So Elasticsearch, I think it's 18, and the rest is the Guillotina. But if you ever needed to use Elasticsearch, you know how much you need to pay. But, okay, we had some instances with that with 10 million objects. 10 million objects are 10 million pages from the Plone point of view. It's not only it's all the objects and the main objects, not the annotations and all the different inside objects on the main object. Then some medium size. Here, what we added. Oh yeah, in the other one, Elasticsearch was monolithical. So if you turn down, you lose indexing. So we were trying to make something really resilient. 3 Guillotinas was already resilient on the terms of the instance. And then now we can have an Elasticsearch cluster, 64 gigabytes of RAM, 8 CPUs. That's 50 millions of objects approximately. And then finally, one of the production environments that we have, 3 Guillotinas, 1 Redis cluster for cache invalidation, and a Postgres cluster or Cockroach if you want to use Cockroach, an Elasticsearch cluster, and 14 CPUs and 96 gigabytes of RAM. This supports nearly everything that you can push to it. Okay, now that we finish with backend kind of DevOps things, it's time of Eric.
So front end, so yeah, Guillotina aims to be a full stack solution, right? So obviously the most important part right now is the back end, so we have been talking about it. But we are also building front end component on top of Guillotinas that are supposed to be reused and could be used by you on any Guillotina-based project. So I will first mention existing tools or product running with Guillotina. So the executioner is basically the equivalent of Django admin. It's built on Angular and it's shipped with Guillotina. It's not, it's not production ready right now. It's still having some bugs. We are not maintaining it very actively, but it looks pretty good and it does some stuff. So I use it to whenever I need to create a new container to do my test or whatever. I'm going to use this tool. I prefer to use that rather than Postman and doing my API call manually like an animal or something. Means those guys. But yeah, so this is a tool which is shipped with Guillotina right now. We will try to maintain it and make it better. But yeah, it's an admin panel basically. That's what it does. We have to mention Volto as well. So when you use Guillotina CMS, you can run Volto on top of it. It's compliant. That's obviously not the main use case for Volto right now. We know Volto is designed to run with Plone, but it is compliant 80%, let's say. So, sure.
Sorry, just because Eric doesn't know what I added here at the bottom of the of the slide, so I'm going just to try to explain. If anybody wants to try Guillotina with Volto and see how all the errors that there are, you can easily, if you know Helm. Helm is a technology on top of Kubernetes, and you can deploy something on a cluster of Kubernetes, even on your local laptop. So if you run Helm repo add Guillotina and this URL, and then Helm install Guillotina, Guillotina CMS, you get out of the box Volto, a Jupyter notebook connected to Guillotina, a Guillotina instance, and executioner. Everything for free.
So yeah, so it does work and it's nice. So yeah, it's definitely something we need to mention here. It's implemented in React, as you all know, obviously. Now I want to make a focus on Grange. So Grange is a new thing that I've been developing those past months. So Grange is a French word. It stands for barn, so basically a place in a farm where you put all your tools and stuff and machines and so on. So that's Grange. But it also stands for Guillotina, REST API, Angular environment. So what it is about. Grange objective is basically the use case is to build web application or mobile application from scratch. Okay, so you use Guillotina as a backend, and then you use Grange to assemble your application fast. And the objective is to make it easy. So you're going to say, yeah, front end, easy, not a good match. Yeah, it's true. Front end is complex. Front end always been it's getting even more complex now. So a lot of frameworks, a lot of knowledge and practice to have. So it's complex, that's true. And my objective with Grange is to make it easy. So that means that you're going to take Grange and you're going to provide you with a lot of ready-to-use component, ready-to-use feature, and then you start from there and you reach the point where you have a MVP which is really satisfying for your application over a few days, right? That's the objective. So how does it work? First, it comes with powerful principles. Principles we know about in Plone for most of them. Traversing is one of them. It was on them. So routing is super bad, and I have a talk about it. I will not go into much details for that, but yeah, it does work with traversing. It also provides view overriding, so it's just like Plone or ZCA kind of approach. So you can have a basic view, which is the one provided by default by Grange, and you can override it for such type. For such given kind of object, you want the view to be different, then you provide your own, you declare it, and it's done, it's going to work. State management as well, so it comes with NGRX configuration. So everything which is traversed, any object you access through the application, going to be put into the state, and it will act as a cache. And it's traversable as well, but here as well, I will not go into too much detail. It's featureful. So compared to the first approach I've been implementing, which was Plone, REST API, Angular, here we are providing everything. Plone REST API Angular, we're just providing the services to connect to a Plone REST API backend or Guillotina backend, authenticate and manipulate contents, create, etc. But it was not providing a UI library, for instance. Here with Grange, you get Pasanaga UI library. So the full thing, really good looking component for forms. You have a beautiful elements like toasters, message, these kind of things. Everything you could expect from a basic UI library is there, right? You have dynamic form generation. So as you know, or maybe you don't know, sorry, but from Guillotina, you can get a JSON schema for any type. And using this JSON schema, Grange going to instantiate dynamically a form which just correspond to this schema. So you can modify, you can view, and you can create new content using this form. You have standard views, so like edit, delete, login, search, whatever. This kind of basic view you use every time in a CRUD scenario. And standard components like breadcrumb, what else? Yeah, some navigation. These kind of things are ready to use, are there. And internalization as well. So that's what you get for free by installing Grange. So that's exactly the principle. You start installing it into your application. So you have an Angular application. You install Grange. and then immediately, with no code, right, just running this install, just like you would run build out, for instance, you install it, and immediately you get everything working for a basic CRUD scenario on any existing object of your Guillotina backend. I think it's any Grange-enabled application is able to render any object content. So of course, it might not be exactly what you need, because that's basic views, standard views, so it's not super rich. If you're not happy with the way it looks, you can provide your own just by overriding the default view for such type, and you get something which is going to be fitting your need, and you can move and implementing the rest of the application super rapidly. So that's the objective. Make it simple. You install, then you create your default views, and you're done. Your application is there. It's all working. And it's looking beautiful. So that's what I'm going to try to show you. If you So it's a very short demo, not super fancy, right? But just to show you what you get with zero code, right? Yeah, not entirely zero code. I made some code to have this beautiful logo, and that's pretty much it. So for instance, you have this view, which is a login page. This is a view. I made no change. Then I get the ability to view the content of my application. So for now, I have one folder. I can enter the folder. You see there is a toolbar. This is also a ready-to-use component. So this toolbar is addressing the basic CRUD needs, like creating, modifying, deleting. So let's add something. So automatically, I go to the add view, which is also for free. It provides me everything which is, sorry, everything which is addable to this, into this current object, into Guillotina. So according what's defined on the backend. This is a vanilla Django, Guillotina CMS setup, so there is nothing but folder and item. But if I declare now a new content, like I don't know what, news item, I'm going to get a news item here, right? It's dynamic. There is nothing to declare on my application. And the whole logic about Grange is this: we are neutral compared to the backend. The backend knows about the structure of the site, the tree. It knows about the content. It knows about the schema. It knows everything. And I don't care about it. I just render. I just react to what the backend is sending me. So he tell me I can have some folder items. Well, let's just display it the way it is. So yeah, I'm going to create something, whatever, and save. And I get it. If I edit, I get this form, which is dynamically generated according to the JSON schema from Guillotina, and it's all working. And yeah, that's it. So you see there is a breadcrumb as well. Yeah, it does work, basically. And everything is cached, it's optimized, everything using the state, the Redux state, which is defined in Grange. So I don't care about anything. I just go implement my views, and it's done. So that's basically the logic. So that's it. Yeah. No, right. Sorry.
Okay, we have the last one. Yeah. So we are going to finish this presentation with the roadmap that we have for the next coming years. Maybe we are going to present some of this in the next Plone conference. Guillotina 5 will be LTS. You want to explain it? Yeah. Well, that means that you can really rely on that Guillotina 5 is going to be kept for a lot of years. We didn't define how many years, but it's going to be maintained for a long time. Then Guillotina 6, it's going to be merge the pull request that supports ASCII on Guillotina in the coming weeks. And that's a big change, but we will be able to integrate with other tools that are supporting ASCII, as it looks like it's going to be the standard protocol for asynchronous applications. And, well, we are maybe going to include also in Guillotina 6 as a concept that it's through the configuration content generation. No? You know that Plone has through the web defining new content types. So as Guillotina, all the configuration is on memory, we are going to allow to create content types and workflows on the configuration at Bootstrap. So they are registered to memory. And yeah, We have some tests and we are playing onto creating a database focus to fix the problems from Guillotina, storing, indexing, searching in Rust. And we are going to play with storing protobuffer serialization instead of pickles. So the database can be inspected and analyzed and by other languages that is not Python. And I think that's all. Thank you so much. Questions?
Any question? Okay.
May I? How do you describe traversal in an open API document?
Can you hear me? Is this working?
Yeah, yeah.
So everything is dynamic. So if you open up Swagger, it's going to be telling you all of the endpoints for a particular context. So if you want to go to a different object on the hierarchy, you have to select that as the URL in Swagger UI, and then it will load all of the endpoints that are available at that context. So it's like a dynamic Swagger.
Cool.
It's a dynamic open API.
Any other question? Okay.
What do you use for payload validation? Open API Core or something else?
Yeah, I mean it's mostly just JSON schema, right?
Okay.
It's all JSON schema actually.
Okay.
So we just read the open API spec, which includes JSON schema, and there's a JSON schema library to validate it.
Question or curiosity? Okay. Where do you use pickles? Because I thought you are storing JSON-B or in Postgres.
Pickles, so we pickle the objects, and those are stored on the database. JSON-B is for the PostgreSQL like indexing. So it's almost like we have index fields, just like say Plone, and then those are stored separately from the pickle in a JSON-B column for Postgres, and then we install indexes on those fields to be able to search them in Postgres.
So I'm already able to access this JSON part with other languages.
What was the question?
You're able to connect to the JSON-B standard Postgres, but
Okay.
it's only the indexing information that you define. You may have a lot of fields,
Okay.
and you just want to index some. So these ones are serialized onto JSON-B.
Okay, thanks. Other question? What?
This is the question for Eric. For someone who doesn't know anything about front-end development, how different is Grange from the current state-of-the-art tools, and what's the main improvement there? Like what?
Okay, so the main thing about it is it's not a framework, right? It's based on a framework which is Angular, and you better know about it if you want to use Grange. I mean, you can start with it because Grange is an easy starting point to learn about Angular. But yes, you will need to learn something anyway. It's not just like magical and you just use Grange. It's not a product that you will kind of configure through a screen or whatever and does everything you need. You are still programming stuff. So you install Grange. It will enable your application with a lot of predefined behaviors, predefined UI, predefined logic, navigation, and so on. So that's good to start with. But then when you need to use it, when you need to customize something in order to fit your business need, that's programming, that's basic Angular programming. The only thing which is really nice about it is you will not need to create your own button click method or whatever. It's all provided with all the different different libraries we are embedding in Grange. So Pastanaga UI, for instance, is ready to use. You just drop the component and it's going to work. You have a lot of form generation as well, so you don't care about that. So it provides you with a high-level toolkit, but still you will need to program. So it's not making it that easy, right? Let's be clear about it.